Today we are performing an experiment in which we will be testing acids and bases. A pH scale is used to determine how acidic or basic substances are. An acid is a substance with a pH from 0 to 7. It typically tastes sour, they turn litmus paper red, and react with metals to form hydrogen gas. A base is a substance with a pH of 8 to 14. A base tastes bitter, they turn litmus paper blue, and feel very slippery. Any substance with either a really high pH or a low one are extremely dangerous to work with. Today we'll be working with baking soda, which has a pH of 9, and vinegar and lemon juice, which has pHs of 2. When solutions of acids and bases mix, they form salt, known as neutralization.
In this demonstration, we will be mixing vinegar, lemon juice, dish soap, and baking soda to produce a controlled reaction in which the end result will hopefully conclude in neutralization. We started the experiment off with a lemon. We then squished and rolled the lemon with our hands in order to release the juices. This would make it easier for the juices to be put into the measuring cup. After rolling the lemon, we then cut it open. After cutting the lemon in half, we put it into a lime juicer in order to squeeze out the juice. We squeezed it into a measuring cup. We did the same with the other half.
Then we moved on to our next step. We scooped a tablespoon, approximately, of baking soda and placed it into the glass. We then took liquid dish soap and squeezed approximately a teaspoon into the mixture. Then the baking soda and dish soap was stirred. Then the lemon juice was poured into the dish soap and the baking soda mixture. As you can see, the acid is reacting with the base, causing it to fizz up. We repeated this experiment once again. We placed about the same amount of baking soda into the cup, as well as adding approximately the same amount of dish soap. We then stirred the two together. In this mixture, we used distilled white vinegar. It has a pH balance of about 2.2. We used approximately half a cup. As you can see, this mixture fizzed at about the same rate that the lemons did. It started to overflow.
Citrus fruits such as lemons as well as vinegar are acids. Baking soda is an example of a base. One major difference between acids and bases are in their ions. Acids have a positive hydrogen ion, while bases have negative oxygen-hydrogen ions. In order for acids and bases to neutralize, one of them needs to be in an aqueous solution. They neutralize as the positive and negative ions bond together. In contrast, when the positive and negative ions separate, it is known as dissociation. The more it dissociates, the stronger electric current it can conduct. The exact pH measure of a substance is hard to obtain due to differences in temperature, other ions present, and the purity of solutes.
A strong base is something that is completely ionic. Some aren't soluble in water. Water is an amphoteric molecule, meaning it can serve as an acid or a base. A weak base does not convert fully into hydroxide ions in solutions. This is the same for strong and weak acids. The Arrhenius theory of acids and bases was originally proposed by savant Arrhenius in 1884. This theory is limited in the fact that it only takes into account the interactions of acids and bases in aqueous solutions. In aqueous solutions, acids and bases increase the concentration of H+ ions and OH ions respectively. H+ ions react with water molecules to form hydrogen ions, making H3O+. Despite the validity of the Arrhenius theory, modern chemists tend to prefer the Bronsted-Lowry theory because it takes into account the different reactions that occur in non-aqueous solutions and gases. In this portion of our experiment, we poured the lemon juice into the baking soda without adding the dish soap. As you can see, it fizzes at about the same rate, but instead of staying up, it goes back down. This is because the soap was not integrated into the mixture, which meant that the suds did not stay. All that's left in the bottom of the cup is a neutralized solution. We then repeated this by adding the distilled vinegar into the baking soda. It fizzled at about the same rate as it had previously. All that's left in this solution is a neutralized mixture as well.
Okay, you have to say
No.
Yeah, say it.
Thank you for watching. Fight, fight, fight.